Okay, this is the question 2 problem. It has to do with Newton's law. So now on this question 2, we have a block of mass 8 kg and it's placed on a horizontal surface, and we can see that it's connected to m kg. The hanging object, the mass is m. So now the only thing we are interested in here is the applied force. We can see that we are given the applied force as 76 Newton and it moves to the right, which it's applied horizontally to keep the system sliding downward at what? A constant velocity. The weight constant means that our acceleration is 0, which is the first thing that you need to note before you do any calculations. Because if you miss, the reason they write it in bold is for you to know that the acceleration is 0 meters per second. If you miss this information, you're going to have a very big problem. So now, if we start answering the question, it says state Newton's law. I want to work on this. Please use your exam guideline to state Newton's law of motion in weights. So now, one thing, what I can tell you guys is that if you hear the question say, state Newton's law of motion in weights, just know that the next questions will have to do with Newton's law. So if you go to question 3 and they say, state Newton's law of gravitational in weights, so just know that the next calculation has to do with Newton's law of gravitational in weights. So even if you go to question 4 and they tell you this has to do with vertical projectile motion, they'll want you to define the free fall and so on. But today we're going to focus on question 2. Right. So on this question 2, they want us to draw a labeled free body diagram of all the forces that are acting on the 8 kg block for 5 marks. So now it's very important for you to note the following. Draw a labeled free body diagram. Make sure that all the forces are labeled correctly. And the 5 marks tells you that we have 5 forces that we need to indicate on that 8 kg block. So let's start answering the question. So this will be the answer for 2.2. Right. So on 2.2, this is my 8 kg block. I can see that this block, it is in contact with the surface. So this tells me that I'm going to have a force acting down, which is the force of gravitation and also the normal force, because it is in contact with what? It is in contact with the surface. So I'm going to have my Fg going down. They said label all the forces. Fg will go down. Then we're going to have a force that is acting up, which is my Fn. So far so good. I have 2 marks already. 2 marks, nice, well done. So now we have to check. There are other 2 forces here. We can see there's a force of tension. So now this is the force of tension. It will act in that direction. I'm going to include it on my free body diagram and say this is my Ft, tensional force. Then now there's an applied force in an opposite direction of the tension. So we have the applied force. Now this is my F applied. So now this is where things starts to get more interesting. Oh, I like this question, because if we go back, they said the force 76 Newton is applied horizontally to do what? To keep the system sliding down at a constant velocity. So now someone will be asking, in which direction is this object moving? Is it going to the right? Is it going to the left? So this is where learners going to make mistake, because they'll say that this will go where the applied force is applied. So the applied force is going to the left. This system will go to the left, which will make the frictional force to go in that direction. So if you say this is your Fk, this is wrong. Listen, this statement is very important. A force of 76 Newton is applied horizontally to keep the system sliding downward. So when we say downward, which force is going down? This one. So this tells us that the mass kg is going down, which will also make the 8 kg block to go in that direction to the left. Even though there's a force applied, but the system still move in that direction. So now this tells us that the frictional force will point in the same direction as what? As the applied force. This is very important. So let's make sure that we don't donate that mark. So now this is my Fk, my frictional force. It will point in the same direction, because now let me explain this. You know, the reason I like physics is that if we can check now, they asked us to find the free body diagram, because if you get your free body diagram wrong, this will affect the next calculations, because the free body diagram, it plays an important role in our calculations you're going to see. So please pay attention. This thing is sliding downwards, even though the force applied, it's applied to the left. It is applied to the left to keep the system sliding down at a constant velocity. So now the frictional force will point in the same direction as the applied force. So now someone will say, hey, they said frictional force always oppose the direction of the motion. Yes, I agree. This is what is currently happening on this problem. The frictional force, the object is moving to the right, so that the mkg can move down. So now where will friction go? To the left. Right, so if you got that one wrong, I mean, if you get it right, you'll be able to do your calculations. Now let's go to 2.3. They say that the coefficient of kinetic friction between the block and the surface is 0.1. We are given the coefficient of kinetic friction, and it's given as 0.2. They want us to calculate the frictional force acting on the 8 kg block. Right. So now what you're going to do is that I need you to make sure that when whatever that they want you to do, they said frictional force. What is the formula for frictional force? You need to write it down. You can get the formula on your answer sheet. Not answer sheet, on your question paper, at the end of your question paper. If we can go down and check if we have that formula. Let's quickly check on this question paper and see if we have the formula. Yes, we do have the formula for frictional force, which is this one. So now it says that Fk is equals to the coefficient of kinetic times the normal force. So I'm going to go back and write my formula down, because there's a mark for that formula. Right, there's a mark. So now I'm going to this is another mark that we can't afford to donate. Okay, just to copy down the formula, we just put it there, then already we have a mark. No, we can't donate that one. So I'm going to say my frictional force is equal to, we said the coefficient of kinetics times the normal force. So someone can prefer to write it like this and say Fk is equals to Uk. The normal force, if we go back to this, the normal force, remember this are vertical object, the normal force will be equal to what? Will be equal to Fg. Let me explain where, okay, let's just leave it like that. The normal force is equal to Fg. So just know that if the object is in contact with the horizontal surface and there's no force that is applied at an angle, the normal force is equal to Fg, which is the same as mg. So someone can prefer to write this as the mass times the gravitation. So no stories, just mass. This is what we are doing. We are collecting the mass. So Fk will be the coefficient of kinetic friction is given as 0.2. This is my UK there. I'm going to substitute this as 0.2. Now I have to multiply this as the mass is for the 8 kg block and 9.8. You just have to punch that on the calculator. So when you put this thing on the calculator, you're going to get an answer of 15.68 newtons. Right. This is how we calculate the kinetic friction. So now if we go to 2.3.2, they want us to find the mass of the hanging block. The mass of the hanging block. So now I'm going to have a problem, because now you know the best thing that you can do, let's say you want to calculate the mass, because first thing first, check the marks. This is 4 marks. The 4 marks tells you that there's work that you need to do. We need to do work. We need to work on this. So now to do this, what we're going to do is that it's best for us to first draw the free body diagram for that. Because if you draw the free body diagram, then that's when you're going to have a direction, so that you're going to know what you need to do. If I draw the free body diagram, this is my free body diagram, and I have Fg going down, then I have the F of tension. You see? So remember that this thing, okay, it's moving at a constant velocity. Yes, we know that it is moving at a constant velocity. So what I'm going to do, because this is the tensional force, we need to first calculate the tensional force. And if we use the mkg, it's going to be difficult. Why? Because we have less information. So this gives us the opportunity to go back to the 8 kg block, because remember we also have tension, and tension is the same for these 2 blocks. So if we can try and start with the 8 kg block to find the tensional force, we can come back and use it to find the mass on this block. So now what I'm going to do, I need to draw a free body diagram of all the forces that are acting on the 8 kg block. And horizontal forces, how many are they? 1, tension, 2, applied force, 3, kinetic friction. So I'm going to redraw my free body diagram here. I'm going to say this is 2.3.2. So on the free body diagram, I'm going to say I have the tensional force going down. Remember, it's very important for you to remember why are we going back to the 8 kg block, because we are trying to find tension. So this is my tensional force, and I have another force going in that direction, which is going to be my F applied. Then I have another force, which is Fk. So now let's choose direction. So I'm going to choose the direction of the motion as positive. So meaning we're going to take right as positive. So now if we take right as positive, this is Newton's law. We're going to use the formula F net. It's equals to ma. So we're going to take all the forces that are going to the right, which is tension. We minus all the forces that are going to what? Let's call this Ft. All the forces that are going to the left, which is Fkn, F applied, and this is equals to ma. But now we can use the acceleration. Remember, it was given that the acceleration is 0. Why? Because of the statement constant velocity. So now it's about time we use that weight, the constant velocity. So the acceleration is 0. What I know is that the ma, this will be substituted at 0, which will make everything to be more easy. Right. So now I know that if we continue with our calculations, what do we have so far? We're going to say this is my Ft, which is what we are trying to calculate, minus Fk. Remember now we know what is the Fk. We just calculated the kinetic friction as what? 15.68. So if you make anything, maybe you make a single mistake or something, then you get this calculation wrong, is going to affect the answer for 2.3.2. So please pay attention. Remember, we don't want to donate those marks. Right? So now, so far, by writing this, you already have the mark. So we need to work and get that 3 marks because we need to collect full marks. Right? So now we're going to minus the FK. We substitute this as 15.68 minus the applied force, which was given as what? As 76 newtons. So I'm going to minus this as 76 and equate this to 0. Now, this is easy. We just have to isolate the tension. We need to isolate the tension because if we isolate the tension, we're going to say that my Ft, it's equals to. So what I need you to do, you're going to add these two guys here. Minus 15, you're going to add it with minus 76 newtons. The answer that you get will be negative, but now I need you to move it to the other side so it can be positive. So what we are trying to do is that we are isolating the tensional force. So if you put it on the other side, they should give you 91.68 newtons. So now we have the tension. What's next? How can we use this tension? So now, so far, if you've managed to do the substitution, you have another mark. They won't give you the mark for the tensional force, but they'll give you the mark for the substitution. I'm going to explain why there's a mark for the substitution. Why not? Why? Because now so far, how many marks do we have? We have how many marks? 2 marks. So now, why they won't give you the mark for finding this tension? The reason I'm saying they'll mark the substitution part is because they want to see if you know that the acceleration is 0. So for you saying that this is 0, you have a mark. So let's see how are they going to mark the next 2 marks. So now we have the tension. You go back to this force. So can you see that this is a vertical forces? We know that we choose direction. Remember, we take right as positive. So you need to pay attention on direction. If you take right as positive, you are forced to take what? Down as positive. Because if we take right, it will move like that. Then when it comes to that part, down will be positive. So now if we take down as positive, from this free body diagram, I have the Ft going up, the Fg going down. So I have to take all the forces that are going down minus all the forces that are going up. Simple. So what we're going to do, we're going to say, from this, we know that Fg, which is the force going down, we minus Ft, which is the force going up, equate this to 0. Then, why are we equating to 0? Because these are vertical forces. So now, Fg, it's equals to Ft, the tensional force. Therefore, we can see that the force of tension, it's equals to Fg. And we know that the force of tension is what? It's 91.68. Now, the Fg, we can write the Fg as what? Mg. So now, yes, we have the mass. We are bringing the M so that we can be able to answer the question. Remember, the question wants the mass. So if you bring the M, now you know what you have to do. This is M. We're going to multiply it by 9.8. Then the only thing left is for you to divide both sides by what? Is for you to divide both sides by 9.8 to isolate the mass. 9.8. Therefore, what is the tensional force equals to? I'm sorry, what is the mass equals to? When you say 91.68, you divide by 9.8, they should give you 9.36 kg. And this is how you answer this question. It's easy. This is how you answer the question. So now, this is how we do this question. Let's see what we have on the next one, which is we still have 4 marks that we need to connect. Ne? We still have 4 marks. So now they say that the applied force now acts down at an angle to horizontal as shown in the diagram below. Okay, so now we are, instead of the applied force being horizontal, it is now applied at an angle. So now, without you getting confused, because we already know the question, what they'll ask. They say, what will the effect on the following be? The coefficient of kinetic friction. How will this affect the coefficient of kinetic friction? So the coefficient of kinetic friction won't change. It doesn't matter how the force is applied. This won't change the kinetic of friction. The only thing that I need to go into more details is 2.4.2. So now the coefficient of kinetic friction will remain the same. So it will remain the same. So the one that I want to go into more details is this guy here, the 4.2.2. I'm going to show you guys why I'm saying that we need to go into more details. So now, there's something that I need you guys to note. The kinetic of friction acting on the 8 kg block. So now, if we check this, let's do something here. Let's go back and see what is going on, because now we are talking about what? The kinetic friction. First, how do you calculate the kinetic friction? We know that Fk, the formula for Fk is the coefficient of kinetic times the normal force. So now let's say you are in an exam and you don't know how to collect these 3 marks, because these are what we call questions that need you to do critical thinking. So this is how you answer this is how you answer the physics question, okay? You underline kinetic friction. They want to know how will this affect kinetic friction. You write the formula of kinetic friction, okay? So from the kinetic friction, we are saying that the coefficient does not change. It will remain the same. So you need to investigate what will happen to the normal force. This is the only thing that you need to do. Because if you understand, if the normal force increase, the kinetic friction increase. So what we are trying to say is that the kinetic friction is directly proportional to what? To the normal force. If the normal force increase, the kinetic friction will also increase. So now the question is that how can we investigate what will happen to the normal force? You go back to the drawing. You're going to draw your, this will be my horizontal component, which is my Fx. Then I'm going to have my Fy pointing up. This is my Fy. So now the free body diagram changes like this. I'm going to have my Fy going up. I'm going to have my normal force, which is also going up. Then we're going to have Fg going down. So now let's calculate normal force. We know that we take, let's say we take up as positive. So I'm going to say I add all the forces that are going up, then we subtract all the forces that are going down, equate this to 0. Solving for normal force will be equal to, this will go to the other side to be negative, this will go to the other side to be positive. So this will give us Fg minus Fy. So this is the formula for normal force. Oh, come on, guys. This is the formula for normal force if the force is applied at an angle. So now, what happens? Let us do some, let's compare. Remember how we calculated the normal force first? Where is it? We said that the normal force is equal to the weight if the force is applied horizontally to the surface. But now, if the force is applied at an angle, it's equal to the weight, then we subtract Fy. So we are reducing what? the normal force. So this tells you that the normal force will decrease. So the normal force will decrease. So the answer here is that the kinetic friction will decrease. Why? Because, okay, let's put it here, the normal force, the kinetic will decrease. And then the reason they want us to explain our answer, because the formula for normal force, even if you write down the formula and say this is Fg minus Fy, you're going to get full marks. Because now we know that the Fg, the normal force, it's equals to Fg, which is mg, minus, how do we calculate the horizontal component? The applied force multiplied by the sine of theta. Then if you give them the formula, you're going to get full marks. So now, or you can say Fk is directly proportional to the normal force. And remember, to find Fk, we use UK times the normal force. And that's how easy it is to collect the 18 marks. That's how easy it is. So just a quick recap. How did we know that the normal force will decrease? So what if we put this in, someone maybe might want us to put it in, instead of putting the equations, what. Someone might prefer us to just write it down like this. If, let's say, when the mass is pulled at an angle, it has what? It has horizontal and vertical. It has horizontal and vertical components. Therefore, the vertical components this vertical component reduces the force pushing, is going to reduce what? Which force? The force that is pushing into the ground. The force that is pushing into the ground, which is the Fg, okay? So now if it reduces the force that pushing into the ground, what happens to the normal force? Therefore, this reduces the normal force. Therefore, this reduces the normal force. So guys, trust me, I know that it won't be easy for you like to study all this thing. Let's try to make our life simple now when it comes to studying. Let's study smart, not hard. Just say decrease, then write the formula, then you'll still get the 2 marks and 1 mark for writing degrees. So now what I need you to do is that think about it like this. Let's say now the force is pushed. Instead of this arrow, let's say it is pushed at an angle. What will happen? So now if it is pushed at an angle, the Fy will point downward. So the Fy will point downward. This will be your Fy. But remember, your normal force is going up. So your normal force will go up. So this will be my, okay, this will be my, let me quickly fix this. Okay. This will be my normal force, Fn. Then Fy will go down with the Fg. So we can see that the normal force, we subtract the Fg and the Fy. Therefore, what is the normal force equals to? Fn will be your Fg plus your Fy. So now we are adding. This tells you that if the force is pushed at an angle, the normal force will increase. How the normal force will increase, how will it affect the kinetic friction? The kinetic friction will increase. So you need to pay attention if the force is pushed or pulled. And that's it for this question. Thank you for watching, guys. If you liked the video, please do subscribe so that you don't miss the next lesson.